Good evening to all. Myself, Paramesh. So today I am going to discuss second year mathematics, chapter 11, three-dimensional geometry. So in this three-dimensional geometry, we will discuss direction ratios of a line, direction cosines of a line, and angle between two lines. We will discuss today. Let us go. In the vector algebra, in the chapter 10, already we have discussed about direction ratios and direction cosines. Let us recall. If I take O is the origin, OX is x-axis, OY is y-axis, and OZ is z-axis. Let the line L, suppose if you take the line L, so there is a line L, it has two directions. Line L has two directions. This line L makes an angles, direction angles with the x-axis, it is alpha, with y-axis, it is beta, and with the z-axis, it is gamma. So alpha, beta, gamma are called direction angles. So for the directed line, we are having two directions. So if you take directed line, if you take the directed line, suppose if I take OP is the directed line, OP is the directed line, then this directed line OP makes an angles alpha, beta, and gamma with x-axis, y-axis, and z-axis. Then cos alpha, cos beta, cos gamma are called direction cosines of the directed line. Cos alpha, cos beta, cos gamma. Cos alpha, cos beta, cos gamma are called direction cosines of a line. And these direction cosines are denoted with LMN. The letters LMN. So direction cosines are denoted with LMN. So L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. So here I told to you it is a directed line. So for a line we are having two directions. So I take the direction, it is directed from O to P, O to P. If you take the reverse direction, then the direction angles become their supplements. That is, if you take the line this side towards this side OP dash, this side, then you will get the direction angles are their supplements. So supplements means you will get, so the supplementary angles are you will get direction angles are pi minus alpha, pi minus beta, and pi minus gamma. Then you will get the direction cosine signs will be reversed. That means you will get the direction cosines of this line is, you will get cos pi minus alpha, cos pi minus beta, cos pi minus gamma. You will get cos pi minus alpha is, you will get minus cos alpha, cos pi minus beta is minus cos beta, and cos pi minus gamma is you'll get minus cos gamma. See now, if you take the directed line from O to P, you got the direction cosines are cos alpha, cos beta, cos gamma. And if you take the directed line from O to P dash, it was reversed. Then you got the direction angles are the supplements, that is pi minus alpha, pi minus beta, pi minus gamma. So you got the direction cosines of this line are reversed. Reverse means sign of the, if the signs will be reversed. Here you got the cos alpha, cos beta, cos gamma, but here you got, see, minus cos alpha, minus cos beta, minus cos gamma. So signs are reversed. So, so these are the direction cosines of this line OP dash, and these are cos alpha, cos beta, cos gamma are the direction cosines of the line, directed line OP, cos alpha, cos beta, cos gamma. So for the directed line, for any line, it has two directions. So that's why we will get the direction cosines of any line are two sets you will get. One is cos alpha, cos beta, cos gamma. Another one is minus cos alpha, minus cos beta, minus cos gamma. Right? So let us know, let you all note this concept. Next, next we will discuss about the direction ratios of a line. Direction ratios of a line. Direction ratios of a line. Any three real numbers, any three numbers which are proportional to direction cosines are called direction ratios. Already we have discussed direction cosines are denoted with LMN. Direction cosines of a line, any line, directed line, are denoted with LMN. So those are direction cosines. Now we are going to discuss direction ratios of a line. The direction ratios of a line are nothing but any numbers. If you take any three numbers, let us take, suppose the three numbers are, I am taking A, B, C. A, B, C are any three numbers. These three numbers which are proportional to direction cosines of a line, such numbers are called direction ratios of a line. So these three numbers A, B, C are proportional to what? The direction cosines. So direction cosines of a line are, we know, L, M, N, and these are proportional to what? Direction ratios of a line. So A, B, C are direction, any three numbers which are proportional to direction cosines of a line. That means you will get the, so LMN is proportional to A, B, C. A, B, C you will get. That means you will get the L is equal to K into A, you will get M is equal to K into B, and N is equal to K into C. That means you will get L by A is equal to K, and M by B is equal to K, N by C is equal to K. Right? Now L is equal to, you will get AK, and M is equal to, you will get KB, and N is equal to KC. N is equal to KC. Now, if you take their sum of the squares, you will get L square plus M square plus N square is equal to, you will get A square K square plus A square, sorry, next B square K square and C square K square. You will get, if you take K square as common, you will get K square into, you will get a square plus b square plus c square. But we know in vector algebra we have discussed, so the sum of squares of direction cosines of a directed line segment, it is 1. So you'll get it is 1. Now you'll get the k square is equal to, you'll get k square is equal to 1 by a square plus b square plus c square. Then k is equal to, you'll get plus or minus 1 by square root of a square plus b square plus c square. K is equal to plus or minus 1 by square root of a square plus b square plus c square. You'll get. Now, if you substitute that value in this, L is equal to AK, L is equal to AK, and M is equal to KB, and N is equal to KC. If you substitute, then you'll get the direction cosines. What you'll get? L is equal to, you'll get the plus or minus a by square root of a square plus b square plus c square, and m is equal to, you'll get plus or minus b by square root of a square plus b square plus c square, and n is equal to, you got plus or minus c by square root of a square plus b square plus c square, a square plus b square plus c square. So generally for any directed line, so we are having two sets of direction cosines. For any line, we are having two sets of direction cosines. But to get the unique directed cosines, we have to take directed line. So if you take directed line, it will that we can understand that line is directed from which direction to which direction, which point to another point. So then we can get the unique direction cosines you'll get. So here L is equal to plus or minus a by root over a square plus b square plus c square, and m is equal to plus or minus b by root over a square plus b square plus c square, and n is equal to root over plus or minus c by root over a square plus b square plus c square you're getting. So these are what? If a comma b comma c, here a b c are called what? Direction ratios of a line. Already we have told. So any three numbers which are proportional to direction cosines are called direction ratios. So direction ratios means what? Any three numbers which are proportional to direction cosines of a directed line is called direction ratios, and those are the direction ratios are denoted with a b c. So now we got the, so if L M N are the direction cosines of a line, directed line, then and a b c are direction ratios of a directed line, then to find the direction cosines of a line, if you know direction ratios of a line, then formula is we can use L is equal to, so a by root over a square plus b square plus c square, b by root over a square, m is equal to b by root over a square plus b square plus c square, and n is equal to c by root over a square plus b square plus c square we can use. Now here observe, if you take a b c, we know for any line we are having two sets of direction cosines. Similarly, for if you take the direction cosines, direction ratios, if the direction ratios of a line are a b c, so for any line we have infinite number of direction ratios, infinitely many number of sets of direction ratios will be there. So if you take a b c are the direction ratios of any line, then ka kb kc, here we got see ka kb kc, ka kb kc, there k is what? K is a constant real number. So then ka kb kc are also the sets of direction cosines. If ABC are the direction, Ka, Kb, Kc are called sets of direction ratios of a line, same line. So if ABC are the direction ratios of a line, then Ka, Kb, Kc are the sets of direction ratios of a line. Here K is what? Any constant. So if you take any line, for any line, they will have infinitely many sets of direction ratios will be there. Infinitely many sets of direction ratios will be there. So that we should remember. So for any line we are having infinitely many sets of direction ratios will be there. But for any line we are having two sets of direction cosines will be there. One is a by one is you will get a, L m n, another one is minus L minus m minus n. That we should remember, right? Next we'll go for next we'll go for next we'll discuss about angle between two lines. Angle between two lines when their direction ratios and direction cosines are given. And before going this, once we will discuss in vector algebra, we have discussed about direction cosines of a line joining two points we have discussed. Let us see. So if you take a three-dimensional coordinate system here, so this is I am taking x-axis, this is y-axis, and this is z-axis. If you take, so here it is origin O, okay. So here, if I take this is a directed line, if you take the directed line like this, if you take, so this directed line for this, O is origin, I am taking, let us see. So we will discuss about angle between, so how to find direction cosines of a line segment, or directed line joining two points, line segment joining two points, right? So I am taking here P is any point in a space, and I am taking here Q is any point in a space. If you join these two, you will get a directed line, you will get a line, you will get directed line, you will get like this. Now draw a perpendicular to, or otherwise you take a draw a perpendicular to xy plane and draw a perpendicular from Q to xy plane. So let us take it is some L, and it is L1 and L2. If you take and draw a perpendicular from P to QL2 line. So I am taking this one. So this is I am taking N, right? Now what you will get this angle? This angle is I am taking, let us take this angle is some gamma. I am taking this angle is some gamma. Now if this angle is gamma, then what will be this angle? This angle also becomes gamma. Now, you will get, if you take a right angle triangle here, you take a right angle triangle here, PQN, if you take cos gamma is equal to, you will get adjacent side by trigonometry, you can take adjacent side by hypotenuse, you will get it is Qn by, you will get a PQ. What is Qn? If I take a P is a point x1, y1, z1, and Q is the point x2, y2, z2. If you take P x1, y1, z1 and Q x2, y2, z2 are 2 points. So I taken these 2 points. Now what you will get Qn length? This Qn is parallel to which axis? It is z axis. It is. Now you will get this Qn length becomes what you will get? You will get the z2 minus z1 by PQ. PQ means it is the distance between these 2 points. What we know already, distance between 2 points PQ is, you will get square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. You will get. Now here PQ means you will get it is PQ. So cos gamma is equal to, you will get PQ. Similarly, we can find, but we know what is cos gamma, the cosine of the direction angle. It is a direction cosine. So we can write it as m. We can denote it as n. N is equal to, you will get z2 minus z1 by PQ. Similarly, we can find, we will get the cos alpha is equal to, you will get x2 minus x1 by PQ you will get, and also cos beta is equal to, you will get the y2 minus y1 by PQ you will get. So here cos alpha, cos beta, cos gamma are direction cosines. Cos alpha, cos beta, cos gamma are direction cosines of a direct line. Already we have discussed. So for this line PQ, the direction cosines of line joining 2 points Px1, y1, z1 and Qx2, y2, z2 is, you will get the cos alpha is equal to x2 minus x1 by PQ, cos beta is equal to y2 minus y1 by PQ, and cos gamma is equal to z2 minus z1 by PQ. But do we know cos alpha, cos beta, cos gamma are denoted with L, M, N. That means the direction cosines of a line joining 2 points P x1, y1, z1 and Q x2, y2, z2 is, you will get the L comma M comma N, L comma M comma N, L comma M comma N is equal to, you will get the, what you will get, x2 minus x1 by PQ, you will get, comma y2 minus y1 by PQ you will get, comma z2 minus z1 by PQ. So the direction cosines of the line joining Px1, y1, z1 and Qx2, y2, z2 is, you will get x2 minus x1 by PQ is equal to y2 minus y1 by PQ is equal to z2 minus z1 by PQ. So this is a formula for finding when 2 points are given in a space. So the line joining 2 points direction cosines to find formula is x2 minus x1 by PQ is equal to y2 minus y1 by PQ is equal to z2 minus z1 by PQ, where PQ is equal to, what you will get, square root of distance between 2 points. These 2 points, you will get PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this is a formula to find distance between 2 points. Sorry, to find the formula for the direction ratios of a line segment joining 2 points Px1, y1, z1 and Qx2, y2, z2, right? And let us we go let us we go the angle between two lines. So, angle between two lines, when two lines direction ratios, if you know what is angle between two lines, when two lines direction cosines, if you know what is angle between two lines. So, let us see here, when two lines are when two lines, if you know, if you take two are direction lines, directed lines, okay. So, the first line directed, the first line direction cosines are, or direction ratios, if you take the first line direction ratios are A1, B1, C1. If you take it as L1 and it is L2. And the second line direction ratios are A2, B2, C2. Then to find angle between these two lines, angle between these two lines, if you take theta is the angle between two lines, then already we have discussed in a vector algebra, to find angle between two directed line segments, that means angle between two vectors. If A1, B1, C1 and A2, B2, C2 are the direction ratios of the two lines, directed lines, then you will get cos theta is equal to, we are having the formula A1, A2 plus A1, A2 plus B1, B2 plus C1, C2 by, you will get the square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. So, if A1 B1 C1 and A2 B2 C2 are two lines direction ratios, two directed lines direction ratios, and theta is the angle between them. To find the value of theta, formula is cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 by root over A1 square plus B1 square plus C1 square into root over A2 square plus B2 square plus C2 square. Similarly, when if two lines are perpendicular, that means they are perpendicular to each other, then angle between two lines is 90 degrees. If angle between two lines is 90 degrees, if you take theta value is 90, you will get cos 90, you will get, then cos 90 values we know it as 0. Cos 90 0 means you will get the 0 is equal to, you will get the A1 A2 plus B1 B2 plus C1 C2 by denominator is equal to 0, by denominator is equal to 0, denominator. If you cross multiply this denominator, you will get it is 0. That means you will get what? A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So, if you take theta is equal to 90 degrees, then you will get cos theta becomes 0. If denominator, if you cross multiply, you will get it is 0. So, when two lines are perpendicular, when two lines are perpendicular, if you get the two lines are perpendicular like this, so here this line direction ratios are A1 B1 C1, and this line direction ratios are A2 B2 C2. Then two lines are perpendicular, condition is what? A1 A2 plus B1 B2 plus C1 C2 equal to 0. When two lines are parallel, then, so two lines are parallel, so it is L1 I am taking, it is L2 I am taking. Already just now I told, for any line we are having infinitely many sets of direction ratios, infinitely many sets of direction ratios. That means if you take A comma B comma C are the direction ratios of one line, for the same line we are having more than sets, more than one set of direction ratios. That means we are having Ka, Kb, Kc are the sets of direction ratios of the same line. KA, KB, KC. Suppose if you take these two lines are parallel, if these two lines are parallel, then we can take the direction ratios of both the lines are proportional. So if you take this one A1, B1, C1 are the direction ratios of first line, and the direction ratios of second line are A2, B2, C2. If these two lines are parallel, then you will get the set of direction ratios are proportional here. So that means you will get what? A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to what you will get? K. So if two lines are parallel, you will get A1 by A2 is equal to B1 by B2 is equal to C1 by C2. That means direction ratios are proportional to each other. So similarly, we can say if two lines are collinear, if two lines are collinear, so one line lies on same line, then also we can say they are uh, we can say those are what proportional. Suppose one line direction ratios are A1, B1, C1. So on that line, if there is any other line is there, suppose if you take this is a line L1, on this line we are taking from here to here another line, it is L2. So if this line direction ratios are A1, B1, C1, and this line direction ratios are A2, B2, C2, then also they are what? Parallel or collinear. Then we can say those are proportional to each other, direction ratios. A1 by A2 equal to B1 by B2 equal to C1 by C2. So if two lines are perpendicular, then we are having, if their direction ratios of a line are we know, then condition is A1 A2 plus B1 B2 plus C1 C2 equal to 0. If two lines are parallel or collinear, then you will get A1 by A2 is equal to B1 by B2 equal to C1 by C2. You will get. So this is about so angle between two lines. When the direction ratios of a line are given, then angle between two lines theta, for finding theta value, you will get cos theta is equal to what is formula we have to use? A1 A2 plus B1 B2 plus C1 C2 by square root of A1 square plus B1 square plus C1 square into root over A2 square plus B2 square plus C2 square. When two lines are perpendicular to each other, that means angle between two lines are 90 degrees. That means they are at right angles, and their direction ratios are E line direction ratios A1 B1 C1, E line direction ratios A2 B2 C2. Then condition is A1 A2 plus B1 B2 plus C1 C2 equal to 0. When two lines are parallel or collinear and the direction ratios are given as A1 B1 C1 and A2 B2 C2, then condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to, you will get some constant, right? Now we will discuss some questions based on this concept, right? Let us see. If a line makes an angles, let us see one example. One example, let us see. If a line makes an angles, if a line makes an angles 90 degrees, 60 degrees, and 30 degrees, 90 degrees, comma 60 degrees, and 30 degrees, with the positive direction of x-axis, with the positive direction of x-axis, with the positive direction of x-axis, y-axis, and z-axis, x, y, and z-axis. Then find the direction cosines of a line. Then find the direction cosines of a line. direction cosines of a line. See, already we have discussed here what they given. If a line makes an angles 90 degrees with the x-axis, if you take this is x-axis and this is y-axis and this is z-axis. So this is I am taking origin. So this is I am taking the line L, the line L. It makes an angle how much? 90 degrees with the x-axis. This angle is 90 degrees I am taking. And for this angle with y-axis it is given 60 degrees and with z-axis it is given, with the z-axis it is given 30 degrees. You can take this as alpha and this is beta and this is gamma. Already we have discussed if a line makes an angles alpha, beta, gamma with the x-axis, y-axis and z-axis, then their direction cosines are what? Cos alpha, cos beta, cos gamma. So that means direction cosines of a line are direction cosines of a line. Solution. The direction cosines of a line are, you will get the cos alpha, cos beta, cos gamma. So what is cos alpha? It is cos 90 degrees. Cos beta is, it is cos 60 degrees. Cos gamma is, it is cos 30 degrees. Cos 90 degrees is 0. Cos 60 1 by 2 and cos 30 it is root 3 by 2. Right? So if a line makes an angles 90 degrees, 60 degrees and 30 degrees with the positive direction of x, y and z axis, then the direction cosines of a line we have to find. So we know alpha is equal to 90 degrees. The line makes an angle alpha equal to 90 with x-axis, and the line makes a beta equal to 60 degrees with y-axis, and the line makes gamma equal to 30 degrees with the z-axis. Then what we got? Direction cosines of a line: cos alpha, cos beta, cos gamma. So we'll get cos 90 degrees, cos 60 degrees, cos 30 degrees. Cos 90 is 0, cos 60 is 1 by 2, cos 30 is root 3 by 2. Let us go another question, same model. So if you take if a line makes an angles, suppose if I take here, if I take here, if a line makes an angles 90, 135 and 45 degrees, 90 degrees, 135 degrees and 45 degrees, 90 degrees, 135 degrees and 45 degrees. Then what you will get? Here alpha value what they given? 90 degrees, and beta value what they given? 135, gamma value what they given? It is 45 degrees. See, you will get it is cos 90 degrees and cos 135 degrees and cos 45 degrees. Cos 90 you will get it is 0, and cos 135 you will get it is minus 1 by root 2, and cos 45 it is 1 by root 2. So the direction cosines of this line which makes an angles 90 degrees with x-axis, 135 degrees with y-axis, and 45 degrees with the z-axis. You will get the direction cosines of a line are, you will get the cos 90 degrees, cos 135 degrees, cos 45 degrees. That is 0, minus 1 by root 2, 1 by root 2 you will get. Right? Let us go for next question. If a line has direction ratios, next example, if a line has direction ratios, if a line has direction ratios 2 minus 1 minus 2, 2 minus 1 minus 2. Then determine their direction cosines. Determine its direction cosines. Direction cosines. See, already here what they given, direction ratios of a line they given, we have to determine their direction cosines. So we know direction ratios of a line are denoted with the ABC. So given solution is given direction ratios of a line, direction ratios of a line are what they given. So direction ratios of a line A comma B comma C are what they given. It is given 2 minus 1 minus 2. Andre A value minus A value 2, B value minus 1, C value minus 2. Now we have to find what direction cosines of a line. Direction cosines of a line. Already we have discussed direction cosines of a line are denoted with LMN, and the formula for finding LMN when the direction ratios are given, that is A by root over A square plus B square plus C square, B by root over A square plus B square plus C square, and C by root over A square plus B square plus C square. So you have to use the formula. So A by root over A square plus B square plus C square, comma B by square root of A square plus B square plus C square, and C by square root of A square plus B square plus C square. So what you will get? You will get it is 2 by square root of, so 2 square is you will get 4, and minus 1 whole square you will get 1, again minus 2 whole square is you will get it is 4. So you will get it is 4, comma, and you will get here minus 1 by square root of, you will get a 4 plus 1 plus 4. And next one you will get minus 2 by square root of 4 plus 1 plus 4. So what you will get? It is 4 plus 4 is 8, plus 1 is 9, square root of 9 is 3, you will get a 2 by 3, and you will get minus 1 by 3, and you will get minus 2 by 3, right? So when the direction ratios of a line are given to find its direction cosines, so given direction ratios we have to take it as A comma B comma C is equal to 2 minus 1 minus 2, and we have to find their direction cosines. So then the formula we have to use is A by root over A square plus B square plus C square, B by root over A square plus B square plus C square, and C by root over A square plus B square plus C square. So it is for 1 marks it will be important, this type of questions. Next, next one. See. Suppose they given find the direction cosines of line joining 2 points. Already we have discussed the direction cosines of line joining 2 points Px1 y1 z1 and Qx2 y2 z2. So based on that concept, we will write one question. Find the direction cosines. Find the direction cosines of the line joining. Find the direction cosines of the line joining 2 points. 2 points. So and the points are minus 2, 4, minus 5, and 1, 2, 3. So here 2 points are given. We have to find the direction ratio, direction cosines of line joining these 2 points. So given 2 points are given 2 points are what are they given? Given 2 points. So I am taking P. One is x1, y1, z1. So it is given as -2, 4, 5, and Q x2, y2, z2. So it is 1, 2, 3. So we have to find direction cosines. Then we know formula is x2 direction cosines of line joining 2 points when 2 points are given x1, y1, z1, x2, y2, z2 is you will get x2 minus x1 by pq, y2 minus y1 by pq, z2 minus z1 by pq, right? So first we will find the distance between 2 points p and q. So let us find. So what is distance between 2 points p and q? So you'll get what? Square root of, so 1 minus of -2, you'll get a 1 plus 2 whole square. Next, 2 minus 4 whole square, and next 3 minus of -5, you'll get a 3 plus 5 whole square. So what you'll get here? 3 square, and here -2 whole square, and here 8 square. So you'll get this is, you'll get 3 square is 9, and 2 minus 4 whole square is -2 whole square, that is 4, and 3 plus 5 whole square, that is 8 square, that is 64. So you'll get you'll get what? 13 plus 64. So you'll get root 77, right? So when the points are given -2, 4, -5, and 1, 2, 3, the distance between 2 points, 1 plus 2 whole square is 9, and 2 minus 4 whole square is 4, and 3 plus 5 whole square is 8 square, that is 64. 9 plus 4, 13 plus 64. You'll get the root 77. But you have to find direction cosines of a line joining. Direction cosines of line PQ or what you will get. So formula is x2 minus x1 by PQ, comma y2 minus y1 by PQ, comma z2 minus z1 by PQ, right? So you'll get the x2 minus x1 by PQ means x2 minus x1 by PQ means what you'll get? So 1 minus of -2, you will get the 1 plus 2 by PQ is how much? Root 77, and next 2 minus 4 by root 77, and next 3 plus 5 by root 77. So you will get 3 by root 77, comma -2 by root 77, and next 8 by root 77, right? Next we will discuss about another model. So when 3 points are given, so we have to show the 3 points are collinear. Let us see. Show that the points A. Next example, let us see. Show that the points A, it is given 2, 3, -4. B, it is given 1, -2, 3. And C, it is given 3, 8, -11. 3, 8, -11 are collinear. Are collinear. See here, we have to show that 3 points are collinear. Generally, we know collinear means what? So, if two or more points lie on same line, so if you take 2 points on a line, if you take 2 points, if you join these two, you'll get a line. If you take any other point on the line, then The 3 points are called what? Collinear points. So we have to show these 3 points are collinear. To show 3 points are collinear, suppose if you take here A, B and C, these 3 points are collinear. To show these 3 points are collinear, first we have to find, so already we have discussed in direction ratios. So for any line we are having infinitely many sets of direction ratios. So first we can find the direction ratios of AB, and we can find the direction ratios of BC, and we can find the direction ratios of AC. So we know for any line we are having infinitely many sets of direction ratios, and they are proportional, That means direction ratios of AB is proportional to direction ratios of BC, or direction ratios of the line AB is proportional to direction ratios of the line AC. So we can take. So let us find first the direction ratios of AB, the direction ratios of BC, and the direction ratios of AC. Let us find. So direction ratios of line AB. So as you know, direction ratios of, how to find direction ratios of line joining 2 points? X2 minus x1, y2 minus y1, z2 minus z1. As we discussed here in the previous, the direction cosines of line joining 2 points is, we know, x2 minus x1 by pq, y2 minus y1 by pq, z2 minus z1 by pq. So here x2 minus x1, y2 minus y1, z2 minus z1 are called direction ratios of a line. X2 minus x1, y2 minus y1, z2 minus z1 are called direction ratios of a line. So here, you know, 2 points, you know, A and B. We have to find the direction ratios of line joining 2 points A and B. So by using the formula, x2 minus x1, comma, y2 minus y1, comma, z2 minus z1, you'll get. So these are direction ratios of first line. What you'll get? So you'll get the 1 minus 2 A and B. So 1 minus 2 is x1 y1 z1, is x2 y2 z2. So you'll get a 1 minus 2, and you'll get a minus 2 minus 3, and you'll get a 3 minus of minus 4. You'll get it is 4 plus 4. So you'll get minus 1, minus 5, and you'll get it is 7. So minus 1, minus 5, 7 are the direction ratios of the line AB. Similarly, we will find direction ratios of line BC. We can find, if you take BC, what you will get? So B is 1 minus 2 3. If you take it is x1 y1 z1, and C is 3 8 minus 11, that is x2 y2 z2. Again apply the same formula, x2 minus x1, y2 minus y1, z2 minus z1. Then you will get it is, so these are, you will get the 3 minus 1. So 3 minus 1, and next 8 minus of minus 2, you will get it is 8 plus 2, and next minus 11 minus 3, minus 11 minus 3. So you are getting here 2, and here you are getting 10, and here you are getting minus 14. Now you see, if you take these are A1, B1, C1, if you take, and these are A2, B2, C2. Now these are proportional or not, let us see. So if you take A1 by A2, B1 by B2, C1 by C2, it gives the same value. So if you take minus 1 by 2, and you are getting it is minus 1 by 2. Other, if you take minus 5 by 10, it also gives what? It is minus 1 by 2. So this is a value of A1 by A2, and it is a value of B1 by B2, and it is a value of C1 by C2. What you will get? C1 by C2, 7 by minus 14. So it is also equals minus 1 by 2. Now let us see here, A1 by A2 value minus 1 by 2, B1 by B2 value minus 1 by 2, and C1 by C2 value also minus 1 by 2. That means the direction ratios are proportional to each other. So if two lines AB and BC are proportional to each other, then we can say the 3 points ABC. So here A, B, C, if you take, so direction ratios of line ABR we got, so it is minus 1, minus 5, minus 7, and direction ratios of the line BC we got, it is 2, 10, minus 14, and they are proportional to each other. If they are proportional to each other, then we can say the two lines are collinear. If the lines are collinear or parallel, then we can say the 3 points are collinear, because here AB and BC are collinear. Then we can say the points A, B, and C are collinear points. So they will write here. So given lines are AB and ACR, sorry, AB and BC are collinear. Therefore, we can say the points A, B, and C are collinear. Okay. In tomorrow class, we will discuss about the equation of a line and shortest distance between two lines, shortest distance between skew lines, and the distance between parallel lines. Thank you.